Good morning all of you, my dear students. Today our topic is electric potential and electric potential difference. Okay, in this topic what we are going to discuss, what is meant by electric potential and how is defined the electric potential difference between 2 points in a conductor, in a current carrying conductor. After that we are going to discuss Ohm's law. What is Ohm's law? Okay, what is the use of Ohm's law? These things we are going to discuss in this class. Then we know that in order to water want to flow from that of one place of the earth to that of the another place of the earth means we know that there must be a difference in height. Difference in height. Here the difference, the height, it is more height and here the lower height. Therefore here the gravitational potential is lesser. Gravitational potential is lesser. But here this point is at higher gravitational potential. Therefore between these 2 points there is a difference in gravitational potential difference. There is a gravitational potential difference. Because of this gravitational potential difference, water flows from higher level to that of lower level. Higher level to that of lower level. Similarly, if we take air current, it is water current. It is water current. Okay. Similarly, if we take air current, air also then at some points in the atmosphere is at high pressure. Is at high pressure. Then some other points found to be at low pressure. At low pressure. Therefore, what will happen? Because of the pressure difference of air. Because of the pressure difference of air, the air will move from that of the higher pressure region to that of lower pressure region, which causes air current. Which causes air current. Okay. Similarly, if electric charges want to flow through a conductor, then there must be a difference in potential. There must be a difference in potential. That difference in potential is known as electric potential difference. Electric potential difference. Then first of all, what is meant by electric potential? Electric potential at a point is defined as electric potential at a point in a conductor is defined as the amount of work done. Amount of work done. Amount of work done in moving a unit charge. In moving a unit coulomb charge. That means in order to move 1 coulomb charge from infinity to that of this point against the electrostatic force of repulsion. Against the electrostatic force of repulsion, we want to do a particular amount of energy. Then that particular amount of energy required to move 1 coulomb charge from infinity to this point against the force of repulsion is defined as electric potential. Electric potential. Then similarly, if we take a conductor, if we take a conducting material, then right now here there is a material AB, then A is at a particular potential. Let VA is the potential at the point A. Similarly, VB is the potential, electric potential at the point B. Then right now, if we want to move a unit coulomb charge from the conductor, from the point B to that of the point A against the repulsive force, then here is also we want to do a particular amount of energy. Then that amount of energy done in moving, a unit positive charge against the repulsive force between the 2 points of a conductor is defined as potential difference. Potential difference. Sometimes we will represent the potential difference as dV, or some other times we can represent the potential difference also by V. Okay, therefore V is equal to, we are able to say that V is the difference in potential. What is the potential at A? Potential at A is equal to VA. What is the potential at B? Potential at B is equal to VB. Therefore, VA minus VB is equal to V, which is called as difference in potential or electric potential difference. Electric potential difference, which is nothing but, if we are moving a charge of Q coulomb, a charge of Q coulomb is moved from the point B to that of A. Then for moving, if we are doing an amount of work W, therefore the potential difference between the 2 points A and B, which is equal to VA minus VB, which is equal to W divided by Q, where W is the amount of work done. W is the amount of work done and Q is the amount of charge which is moved. Otherwise, this equation W, the amount of work done in moving a charge from one point of the conductor to that of the another point of the conductor, W is equal to V into Q. V into Q, where V is nothing but difference in potential between the 2 points of the conductor. Okay, then both the difference, potential difference and the potential are measured by the unit volt. That is, volt is the SI unit of electric potential. Volt is the SI unit of potential. Then right now, in order to define, how we are going to define the unit volt? Okay, suppose we know that potential difference or potential difference W is given as that means potential difference V is given as V is equal to W divided by Q. Then if we are moving a charge of 1 coulomb, that is the charge moved from one point to that of another point of the conductor, Q is equal to 1 coulomb, and in order to move this 1 coulomb charge from one point of the conductor to that of the another point of the conductor, if we are doing a work of 1 joule, therefore then substituting Q as 1 coulomb and W as 1 joule, therefore V is equal to 1 joule per divided by 1 coulomb, which is equal to 1 joule per coulomb. Then the SI unit of potential difference or potential is volt, therefore 1 volt is nothing but 1 volt is equal to 1 joule per coulomb. 1 volt is nothing but 1 joule per coulomb. Okay, then right now here we are able to define from this expression, we are able to define 1 volt as the amount of work done in moving a 1 coulomb charge from one point of the conductor to that of another point of the conductor. Okay, that is, if 1 joule of work is done in moving 1 coulomb charge from one point of the conductor to that of the another point of the conductor, then the potential difference between the 2 points of the conductor is defined as 1 joule. For example, there is a problem. Okay, here a charge 10 coulomb charge is moved in a conductor from one point to that of another point. Then in order to move this 10 coulomb charge, we are doing a work of 100 joule. Then what is the difference in potential between the two ends of the conductor? That is, V is equal to W divided by Q, which is equal to 100 joule divided by 10 coulomb, which is equal to 10 volt. Therefore, here the potential difference between the two ends of the conductor is 10 volt. Okay, then right now next our topic is that Ohm's law. Okay, George Simon Ohm related the current flowing through the conductor and the potential difference across the conductor. Then that relation is known as Ohm's law. That relation is known as Ohm's law. That means George Simon Ohm related the current flowing through the conductor. Current flowing through the conductor. Here there is a conductor. Then through the conductor a current of I ampere flows through it, means then the difference in potential is V volt, means the difference in potential is V volt, means then these two things are related by George Simon Ohm and is called as Ohm's law. According to Ohm's law, at constant temperature, when the temperature of the conductor remains constant, okay, then the steady current, that is constant current. Steady current means constant current. The steady current flowing through the conductor is found to be directly proportional to the difference in potential across the ends of the conductor. That is, according to Ohm's law, I is directly proportional to V. Otherwise, if we take this V left hand side, we are able to write this term as I by V is equal to a constant. In a conductor, when the temperature remains same, I by V always found to be a constant, where I is the current flowing through the conductor, V is the potential difference across the conductor. Okay, then here the constant is known as proportionality constant, and the proportionality constant found to be 1 by R. Therefore, according to Ohm's law, we are able to write I by V is equal to 1 by R. Or otherwise, here this can be otherwise written as I is equal to 1 by R into V, where 1 by V is the 1 by R is the proportionality constant, or I is equal to V by R. Then we know that I is the steady current flowing through the conductor, V is the potential difference across the ends of the conductor. Then what is this constant R? R is nothing but the resistance of the material, resistance of the conductor. Then right now here the otherwise this can be written as V is equal to IR, or R is equal to V divided by I. Therefore, from the Ohm's law, we are able to define the resistance of the conductor as the ratio of potential difference across the conductor to that of the steady current flowing through it. Then the unit of resistance is Ohm, named after the scientist who gave the Ohm's law. Then right now here, in order to find out the resistance of a conductor, that means the resistance of a material or the resistance of a conductor can be determined using Ohm's law. Okay, then right now here, to find out the resistance of a given conductor, the simple electrical circuit is like this. Here there is a battery, then negative terminal of the battery is connected to that of the key, and then to that of a rheostat. Okay, it is the rheostat. It is used to vary the current in the conductor. Okay, then right now here there is a conductor XY, say nickel wire, nichrome wire or platinum wire. Okay, then right now the between the 2 points X and Y, the nichrome wire whose resistance have to be determined is connected. Then to measure the current flowing in the conductor, an ammeter is connected in series with the battery and the resistor, and in order to measure the potential difference, a voltmeter is connected across the ends of the conductor. Then it is the simple circuit to determine the resistance of the given conductor. Then right now, by changing the rheostat, the current flowing through the conductor is varied. Then here the current flowing through the conductor, which is represented by I in ampere, it is measured. Then the potential difference across the conductor, difference in potential difference across the conductor is measured by the voltmeter. Therefore, then V in volts. Then by changing the current, that means first we are passing 1 ampere current, then the potential difference is measured using voltmeter. Then 2 ampere current, then the potential difference is measured, and also 3 ampere, 4 ampere and 5 ampere. That means by varying the rheostat. The current through the conductor is varied and the corresponding potential difference is measured. Okay, then right now in each and every case, if we divide the V by I, that is the potential difference across the conductor is divided by the current flowing through the conductor, then we are getting V by I, which found to be almost a constant in each and every value of current and the voltage. Then this constant is the resistance of the nichrome, that is R is equal to V by I ohm. Then right now, taking the resistance along the x-axis and the current along the y-axis. Okay, here y-axis, here the x-axis. Along the x-axis, the potential difference across the conductor is taken. Along the y-axis, current in ampere is taken. Then we are getting a straight line. Okay, that means the plot between the V and I is always a straight line. Then if we find out the slope of the plot at any point, then that slope will be equal to that of that means 1 by R. 1 by R is equal to I divided by V, where I by V is the slope. Okay, then the slope found to be reciprocal of the resistance, or R is equal to reciprocal of the slope, which is equal to V by I. Okay, therefore using Ohm's law, they are able to determine the resistance of the given conductor, given material of the given wire. Then we will meet in the next class. This resistance is different for different conductors, or the resistance is different for different resistors. Okay, then we will meet in the next class. Thank you.